suppose John is a guy starting his own startup and with an expectation to make it big sometime, right? Initially, John has very less number of requirements. So what John did is that, okay, let's start with a single machine and I'll scale up as, the time goes and the number of customers increases, right? So he started with a single machine. Now the load has started from multiplying from one customer to thousands of customers. What would happen is that John's single machine, the machine he initially got for his service, is now not able to handle the load, right? What would happen is that, okay, how he will be able to serve the request for the customers, right? What is the solution here? Well, that's right, the scaling is a solution. And as we talked about vertical and horizontal scaling in the previous video, right? So what we need to do here is that let's say John has decided about horizontal scaling. So what he'll do is he'll start adding the number of servers to his already onboarded server, right, to serve the service traffic. What would happen now? Let's say John has added like 3 servers onto the same service, which already had 1 server already, right? And one problem occurs here. What's the problem? How do John or even the servers know which server would be serving the traffic? There may be a chance if the traffic is not, let's say John has added like, let's say 3 servers, right? And still only the first server which was originally added is being hit continuously. What would happen? That server is bound to fail at some point of time because other 3 are still sitting idle, right? So what John needs to do is balance the load across all the 4 servers, right? And ensure that all the servers are serving the request. Well, that's the concept being called as load balancing. Okay. So now while thinking about load balancing, the first idea comes to mind is hashing, right? So basically in hashing, what we will be doing is we will use a hash function. What it does is it will basically hash the value of a request coming into the server, and we will do basically with the hash function we'll get a certain value. We will mod out that value with the number of servers. So basically m mod n, right? Whatever the result comes out to be, that is kind of the server we will be assigning the request to. Basically that server would be serving the request. Okay, so let's say we have a hash function hn. Okay, so for hash function hn, let's say I have 4 requests. For request number 1, we get a particular value as 8. Right, for request number 2 we got value as 7, for request number 2 we got value as 2, and for request number 4 I got value as 5. Now since there are 4 servers, right, so what would happen is hn of r1 mod 4 would be 8 mod 4 equals 0. So we got the value 0, we would be assigning the server r0 to the request for serving the data. Similarly for R2 I got like 7 mod 4 equals to 3 for R3. Similarly 2 mod 4 is 2 R2 and 5 mod 4 is 1 R1. Okay, so we are assuming that the load is nicely and uniformly distributed across the servers, right? Now what if I have some data which will be cached, right? Let's say my request ID is not a randomly generated request ID. It may be, let's say I am putting user IDs, right, for fetching a particular user data. What would happen is generally any kind of service would be saving the data in a cache of the server, so that the request is easily fetched and we don't have to go to a database to fetch the data. So what would happen is that, okay, server would have a local cache and it will store the data. So now in the scenario, right, since we have only 4 servers, the request 1 would always be going into server number 0. So basically its data is cached in that particular server. Now what would happen is, let's say everything is warm and cozy and John's business is very going very nicely, right? 4 servers are handling the load nicely, and now again there is a sudden jump in his business and John wants to add another server. Okay, so what would happen is we have like 5 servers, right? John added S4 as the 5th server. Now, if you go back and recall, what was the method we used for calculating which server to be serving the request? The method was m mod n, right? M is the solution for hn brackets request, right? So basically whatever the hash function is giving for the request, we are getting m, and similarly what we are getting for m mod n would be the value for the server, right? Now previously the n value is 4, right? But now since the value have changed for n from 4 to 5 because we have added another server, right? What would happen is that this whole calculation would be in the shambles, right? Because 8 mod 4 was 0 previously, now it is 3. So basically the cached data was stored initially in server number 0. Now what I have to do is I have to move this data from server number 0 to server number 3 so that server number 3 can serve the request with the as well as the cache the data, right? Similarly, this whole data needs to be moved around based on the calculations, right? And it is not a very cheap solution. It does take time, and as well as it costs a lot. So what's the solution here, right? Well, a lot of like-minded people came together and thought of a solution called consistent hashing. Okay, let's talk about what is consistent hashing. So for the sake of understanding consistent hashing, let's say we already hashed the request. Now we are going to hash the servers as well. Okay, and let's put all the servers in a ring structure to understand better, right? Let's say my server number 0, the hash value comes out to be 10, right? For server number 1, hash value comes out to be 50. For server number 2, it comes out to be somewhere around 180, and for server number 3 it comes out to be around 260. Okay, so basically they are across the ring. Now what would happen is that, let's say a request is hashed, right, and all servers are also hashed. So what would happen is that the request is hashed and the value is put on the ring. Let's say the value comes out to be somewhere around 5, right? What would happen on 5, since my server number 0 is at 10, my request would be sent to the nearest server in the clockwise direction. So basically we will be moving in a clockwise direction for each request. Basically whenever the request is mapped onto that particular ring, let's go clockwise direction, whichever is the nearest server, it would be serving the traffic. Okay, so since the request number 1, let's say its value is 5, now it is going up to be server number 0, which would be serving the request, right? Since its value is 10. Now coming forward, there may be another request number 2, which would be somewhere above 10. It may be like value 30 or 40. Basically server number 2 would be serving the traffic, right? Or I would say server number 1, my bad. And similarly the request would be mapped across the ring, right? So it's all warm and cozy right here, that let's say all the servers are in the ring and all the requests are being served in a clockwise direction. So ideally all the servers should be serving the traffic, right? It's all good until we have 4 servers, right? As we talked about the 5th server initially with the normal hashing, let's put that server in the picture. Let's say I am putting server number 4, S4, which is the 5th server. So let's say I am putting server number 4 between server number 0 and server number 1, which would be somewhere between 10 and 70. I'm putting, let's say, S4 at 50. What would happen is, now any request coming from between 10 to 50 would be served by server number 4, right? Similarly, any request coming from 50 to 70 would be served by server number 1. Okay, now since previously all the requests from 10 to 70 were being served by server number 1, what would I need to do is I need to move all the cache values which were between value 10 and value 50 to server number 4, right? It is still a costly operation, but not as costly as moving the data around across all the servers, right? It's still there is some kind of cost efficiency here, right? So on the ring, my server number 0 is at 10, my server number 2 is at 180, server number 1, which John has removed, was at 70. What would happen is that all the requests which were being served by from 0 to 70 by server number 1 will be moved and served by server number 2, right, which is at 180. What would happen? All the load from 0 to 180 would be served by server number 2. Okay, previously this load was halved or maybe reduced to a very good extent by server number 1, and now my server number 2 is getting almost twice or maybe 1.5 times of load than it should already have. What would happen? Pretty simple, right? That server number 2 would fail, right? Because it cannot handle that kind of load. Okay, so what's the solution here? Well, the solution is multiple hash functions, right? So what we'll do is we will have multiple hash functions hashing the value of each server, right, and putting the values onto the same ring. So let's say I have 3 hash function, hn, hn1, hn2. hn is the initial function which we are using for servers hashing, right? So hn was initially putting server number 0 as 10. Let's say hn1 has put server number 0 at 30, and also it puts server number 0 at basically h2 puts server number 0 at maybe 120, right? What would happen? There are 3 entry points for server number 0. So any request coming in at any given entry point would be served accordingly in the clockwise direction. Similarly, other servers would be also have multiple entry points. What would happen that, okay, in case of multiple failures coming in, let's say as we talked about S1 being failed and we removed S1, what would happen is that still there are multiple entry points between 0 and 180, which would ensure that, okay, other servers are also taking in the load little by little, which would be much more cost effective, as well as it will also reduce the load on a single server in case a server is added or removed, right? So that is the concept of consistent hashing. I hope you liked the video, you understood the concept, and please share your feedback in the comment section.